So good morning everyone, this is Manas Patnaik, your friend and tutor. And in today's video, we are going to be solving 12th December 2024 engineering graphics question paper, which appeared in the University of Mumbai. So I found this paper to be quite challenging, but 6 problems were given to you, out of which you were supposed to solve only 4. So you have to choose those questions very carefully. Only choose the easy questions, which will ensure that you get maximum advantage, you get maximum marks, right? That's the first thing. Secondly, watch the entire video. Okay, I would suggest you to watch it at a higher speed, 1.5x or 2x if you can manage. Thirdly, the PDF notes of all the problems are available on my app. You can download the app, the link is in the description. You can go to the engineering drawing course. Okay, inside the content section you'll find this folder, a university wise folder. Go inside that, you'll find University of Mumbai, Pune University, JNTU. Select your university, which happens to be University of Mumbai. Inside you will find the PDF notes of this entire 12th December 2024 paper, and use it to the fullest. Okay, so let's begin the session. I hope this is going to be very beneficial for you. And one more thing, do share this video and the link to my application with your friends and classmates so that they can also benefit. Okay, today I'm recording this video on 21st, and right now raat ke 1 baje hai, it's 1 a.m. Okay, so I'll be uploading the video today itself when I wake up after a sleep in the morning, right? So I wish all of you all the very best. Okay, so don't worry, have confidence, and do have a look at each and every questions. Do observe, in fact, how solid lines are made, how hidden lines are made. All of these things really matter, make a lot of difference, right? So with that being said, let's begin the session, and here we go. Question number 1, and here we go. So this is based, question number 1A, this is based on an involute. Let's read it, and then the solution will be done in the next 3 to 4 minutes. It's a very easy problem, 6 marks. Okay, very easily captured. Draw involute to a pentagon of side equal to 40 mm. Pentagon, 5 sides, all of them equal to 40 mm, having one side on ground. Well, this data is superfluous, not needed. Also draw a normal and a tangent at any point on the curve. So once you've made the curve, you need to fix a point over there and then draw a tangent and a normal. Can be done easily. Let me start with the solution. Here we go. So the first thing is to make a regular pentagon. Okay, although nowhere in the question it has been mentioned that you need to draw a regular pentagon, only the word pentagon is mentioned. However, we will assume it to be a regular pentagon. All the sides will be 40 millimeters each. And if you're wondering as to how this pentagon can be created, please listen. This exterior angle 72. This exterior angle is double of 72, so you can do this as 144. Similarly here, this angle is going to be again 72, and this angle will be double of 72, 144. Okay, so finally these two lines are going to intersect somewhere here, and that is going to give you 0.3. Done. In involute, we actually trace the locus of a point, okay, or any one end of the string, right? That is that the path traced by it is the locus, which is popularly known as an involute. That is what we need to do. So if you watch carefully here, the length of the string has been taken as 200. Why? In the question, nowhere the length of string has been mentioned. So we are going to assume that the length of string is going to be equal to the perimeter of the pentagon. And you can see one side of the pentagon is equal to 40 millimeters. So there are as many as 5 sides. 40 into 5 is equal to 200. So this is something that you need to do. And after every 40 millimeters, you need to just mark a point. Okay. And if you watch carefully, I have made these arcs. Okay, your choice, make points, no problem. Now what to do? In the next step of construction, what we'll do is we are going to produce this line from 1 to 2. We are going to go beyond 2 this way. from 2 to 3, beyond 3 this way. I hope you got this, something of this sort, right? Okay, so this is going to give us an idea as to how much portion of the string will come into contact either with 1 2, then 1 2 3, then 1 2 3 4, and how much will remain. So initially the string is in this fashion. After a certain point in time, this 1 dash 2 dash will come in contact with this 1 2, isn't it? So how much would remain? Sir, only this much would remain from 2 dash to P. So basically keep one leg of your compass at 2 dash, other leg at P, and now with 2 as the center, cut an arc. This is going to give you point P2. Okay, so that's over, 2 P2 over. Now with this much, 3 dash P as the radius, and now with 3 as the center, cut an arc again. That's going to give you P3. Simple. In the same fashion, you can get P4 and P5. Done, so very easily. Now you need to join all of these points in proper sequence so that you have a beautiful curve, popularly known as an involute. Now how to do this? Take a look. Sir, how did you make this? It's a smooth curve, yes, but this curve basically can be made with the help of a compass. Let me tell you why. If you take a careful look, this length of the string, this length of, these are the different locations of strings, and these are the points. This is P01, let's say P02, P03. So, but in all the cases, the length of the string remains same. When I say same, this length happens to be 200 exactly between these 2 points, that is P and P2. Yes sir, agreed. So what we'll do is we'll simply take 1 P as the radius, with 1 as the center. We'll make an anti-clockwise arc until we reach P2. In the same fashion, now with 2 as the center and 2 P2 as the radius, go anti-clockwise until you reach P3. Try to follow the same steps. P3 to P4 with 3 as center. Now with P4 to P5 with 4 as the center. And then finally from P5 to this one with 5 as the center. This is going to give rise to a curve that is popularly known as an involute. And as far as tangent and normal is concerned, make a point. Okay. This length, you know how much this length is, sir. It is equal to 200. So by default, this becomes your normal. And now you can keep your protractor over here at an angle of 90 degrees. Draw a line that becomes your tangent. So damn simple. So the next question number 1, part B, is based on orthographic projection, and it's a beautiful question. We can do the solution in the next 5 minutes. Here we go. Okay, so there are as many as 3 parts. We have to make the front view from X. That means you have to watch it from over here and then create the entire front view. Okay. Secondly, you need to make the top view, and then in final third part, which is for 1 mark, you need to place or insert as many as 6 dimensions. Can be done easily. Take a look at this. Take a look. I want all of you to observe this object very carefully. First thing that you should realize is that the length of the object is 96. What is this? Sir, this is the length. Let me write L. What is this? Sir, this happens to be the width. What? Width. What about this dimension over here? Sir, that's the height. So we have the length, width, and height as 96, 64, and 64. Done. With this, we are going to create 2 boxes. One for the front view. You know very well this is 96. That's 96. And then secondly, the height, you know, is 64. This also width, which can be seen in the top view, is again 64. Done. So far so good, no issues. What is the next step? Sir, it has been asked to create the front view when viewing from X, that is from over here. From over here, right? Okay, so what you basically will see, the easiest way to approach this question is to start by creating the front view. In the front view, you're going to see this. Please observe the yellow portion that I'm marking. This is what you'll see. Okay. Yes, I know very well this is a curve over here, a sort of an arc, quarter circle you can say, okay, which has a certain amount of thickness, width, 16 millimeters. This is but if you view it from the front, this curve would look like a straight rectangle, a strip. Okay, that is 16 millimeter wide. If you look at this is going to be 96 by 16. If you look at this strip over here, this is going to be 16 by the depth is going to be 64. So first of all, we are going to mark this sort of L shape over here. Done. So this, by the way, 16, that's 16, that's 96, that's 96. Done. Okay. Now what? The next profile that I'm interested in is this. Take a look. How much is this? 8. What about the diameter of this semicircle? It is 24. What about this length of the edge? This is 8. What about this over here? This height is 28. Okay, so I want all of you to have a careful look. 8, 24, 8, and this height is 28. Right? Where is exactly this point? Somewhere here. Okay, if you watch it from over here, you are watching it from the front. This point will have a projection over here. Yeah, basically. So at a height of 28, let me do this. Yes, sir, this is 28. Done. This is 8, and then this is 24, and then this is 8 again. You know very well that this is 28. Done. What's next? This point and this point. When you view it from the front, they are going to overlap. Yes, sir. Here. And you can simply now make this inclined edge this way. So the front view is almost done with one hidden feature yet to be created. If you watch, there is this circular portion over here. So we are viewing it from the front. It starts here. Okay. So if it starts over here, some information has to be given in the form of, it's a hidden feature. So there is got to be a dashed line. How far is this feature from to the right? If you watch it, this is 20 plus this much. How much is it? So, sir, this happens to be 16. Half of 16 is 8 to the right of center, 8 to the left of center, 8 here also. It happens to be the radius. So basically it is 20 plus 8, that is 28. So at a distance of 28, you can make this hidden feature. Okay, with the help of a dashed line. Done. Okay. So far so good. I'll finish this in the next 1 or 2 minutes. Okay, so the front view is done. Now let's have the projectors through all of these very important points. Right? And the final slide that I'll show you will have the dimensions proper. We'll have the edges with solid and thick lines, and the projectors with very thin and light lines. You'll see that. Okay, so wait for it. Now, when you view it from the top, you are going to see this. Take a look. This portion over here at a distance of 16. This entire curve arc that you see will look like a line this way, a line. Yes, agreed. What about these lines, sir? These are going to have a length of you need to calculate this. Basically, this is 64. Take a look. 64 minus 22. 64 minus 2 is 62, and then minus 20 will give you 42. So that's 42. 42, 42, 42, 42. And these distances, well, they can be referred from over here. So these are all 42, 42. Okay, I hope you got this. And then you can draw this in the top view would look like this. So damn easy. We are almost done. Now, as far as this very portion is concerned, from over here, what we can do is we can simply make a point at a distance of 16, and then from here, again make a point at a distance of 16. Let's do it. And this edge. This. 16 and 16. How far? Sir, this is 20. 20, 20, 20, and then you can take the center and then make the semicircle. Done and dusted. The only thing left is now representation of these lines, some of them solid, thick, some of them um, thin, and here it is, the dimensions as well. That's the entire solution. Okay, so if you can make such a drawing, I am sure that you're going to get full marks for it. Okay. Okay, now we are going to kick off with question number 2, which I personally think does not deserve 15 marks. Okay, so if you just try to make a comparison between problem 2 and problem 3, this is way difficult. Question number 3, sectional orthographic, right? So given the option of attempting 4 questions, I think you should definitely go with problem number 2. Okay, very beneficial. You can save time. Anyway, so we are essentially talking about a pentagonal pyramid. Here it is. Side of the base 40 millimeters. So all of these sides are 40 millimeters. And if you watch carefully, there is a center over here. From the center to the apex, the line connecting the two is what is known as the axis, whose length happens to be 70. Stand on an edge of the base. So this pyramid is standing on an edge of the base. So on this edge, let's say. Okay, and obviously when this happens, either its base will be making some angle that will be given to us, or the axis itself, axis from this very point to this very point, okay, that is going to make some angle. Axis inclination has been given as 45 degrees with respect to HP. Wonderful. And top view of the axis is inclined at 30 degrees to the VP. Okay, this is getting a bit confusing. Axis making an angle of 45 degrees with the HP, and axis also is making an angle of 30 degrees with the VP. But if you read carefully, here the top view of the axis is making an angle. So this is going to be a beta value. This is going to be a theta value, right? You need to draw the projection of the pyramid. I think it would be better if we can straight away start. Let me just switch over to this mode, and so that you guys can understand this in a better fashion. Can you see this? Okay, so take a look. This is a pentagonal pyramid. Okay, so where is the axis? From here until you reach here. That's the axis. Okay, now it has been kept like this. As you can see, one base edge is in contact with the horizontal plane always. Okay, and simultaneously the axis is making some angle with HP, right? So this happens in your step number 2. This is for your step number 2. This is going to be your step number 1. Please remember, if you watch my initial lectures, I have also given a standard procedure for projection of solids, which states that if the axis is inclined to HP, assume the solid. In step number 1, you can assume the solid resting with its base on HP. However, if the axis is inclined to VP, you can assume the solid with its base to be resting on the VP. By the way, the screen can be assumed as VP, and this table top can be assumed as the horizontal plane. I hope you got this. Okay, so this is going to be your step number 1. Front view, top view, top view. Okay, all the 5 triangular faces is going to be visible to us, right? And this is going to be your step number 2. This is how the object looks from the top. This is how the object looks from the front. Okay, and in step number 3, I think it would be better if I can just make these 2 steps, the drawing of these 2 steps, and then we can continue with step number 3, where the axis has to be inclined. Okay, so let's begin. And it would be better if you watch base and axis length. Base, that is 40, has been given to us. Let me just switch to the normal mode. And height or length of the axis is 70. Secondly, the axis is at an angle of 45 degrees with the HP. So theta axis, that is 45. Top view of the axis is inclined at 30 degrees to the VP. Top view is associated with beta. Remember, in projection of lines, theta is the angle made with true length. Phi also is the angle made with true length. But when we talk about alpha, that is different. Okay, So whatever angle the final front view makes with the horizontal plane, that is alpha, and whatever angle the final top view makes with the vertical plane, that is beta. And here the angle made is with the VP. Who is making that angle? Top view. So we are essentially concerned with beta. So beta has been given to us as 30 degrees. So all the things will fall in place. Don't worry. In the next 5 minutes, we are going to crack this very, very easily. Here we go. Right. So let me implement these two datas first. I'm assuming that you guys know how to make a pentagon, don't you? Here it is. Okay. 5 triangular faces can be seen clearly. Okay. Now, the dimensions. Please insert the dimensions always. Otherwise, 1 or 2 marks will be deducted. Draw the projectors, and then can you see this side A, B, C from the front? Yes, sir. Yeah. This is the foot of the axis. The height of the axis is 70. And now you can connect all of these 5 corners with the help of these lines. Okay, these are 5 corners, not 3 corners. Okay, they are getting overlapped because EO is exactly behind AO. OD is behind OB, and so on. Done. What's next? In the next step, we always go for axis inclination. That is step 2. What will we do? Please note, if axis is inclined at an angle theta, then the base will be at an angle of 90 minus theta. And you know very well that here the axis is at an angle of 45 degrees. So the base will also be at an angle of 90 minus theta. That is also coincidentally 45 degrees. So if you keep the base, this base over here at an angle of 45 degree, you'll realize that this axis will automatically become 45 degree inclined with HP. That's true. Okay, as far as the points are concerned, these can be marked very easily. So you take this much as radius from A dash to B dash. With A dash as center, you can cut an arc over here. You're going to hit the location of B dash. Okay, this way you can locate C dash as well. Now connect. Done, sir. Now we are going to view this from the top. So we have drawn the projector lines, and from here also we are going to draw them. If you watch carefully, that's for O. This is for O. So that's the location for O. Similarly, this is for D. This is again for D. So that's the location for D. I'm sure all of you know this, right? So we are solving a question paper. So this is going to be a quick explanation. Okay. How does it look like? Sir, O dash, C dash, since we are viewing it from the top, this edge is clearly visible to us. Clearly visible to us. In fact, this triangular face also will be visible to us. So BOC, COD, BOC, COD will be clearly visible to us, which you can see. In fact, this corner D of the base is outside this edge OD. Now, this being outside, you have to make, or you have to connect E with O and D with the help of solid lines, and the same case is with A as well. Okay, connect with solid lines. If A or E, both of them would have fallen inside this OD edge, let's say E would have fallen between somewhere here, then E to D and E to O would have been hidden lines, that is dashed lines. Right? So far, so good. So basically here, I made a small mistake. I don't know if you guys realized it or not. Whatever data has been given in the question should reflect in your drawing. In fact, there is no data of the base given. Okay, this was my inference. Instead of writing this dimension, I should have written this. Yes, I fixed the base at an angle of 45 degree, but that 45 degree shouldn't have been mentioned. This 45 degree that the axis makes with respect to the HP should have been mentioned, and you guys do that. Okay. Now, in step number 3, this is going to be very simple. You have to recreate what? Recreate. Do it. If you watch, this entire figure is inside a rectangle. So we are going to make a rectangle. Okay. And axis is somewhere here. If you watch, this is the top view of the axis. top view of the axis, and no, this is the front view of the axis. This is going to be the top view of the axis from here to here, right? That's the top view of the axis. This top view is inclined at 30 degrees, which has been given in the question. Now, this top view of the axis is parallel to this side and this side. And if you watch this entirely, it's a rectangle. So if I rotate the rectangle in such a way that this line is at an angle of 30 degrees, this way, this line is at an angle of 30 degrees, then automatically this axis, since it is parallel to it, will become at an angle of, or will fall into an angle of 30 degrees automatically. Okay, this way. So you just need to recreate. You know how to recreate. Okay, and if you don't watch my initial videos, right, I'm not going to get into the details of each and every construction step, right? This way. One more thing, if this side is at an angle of 30 degrees, then this side automatically will be at an angle of 60 degrees. Watch. This angle is 60 degrees. This angle is 30 degrees. Okay. Simple logic. You can save space, you can save time. And yes, you need to recreate this. This point C has to be located right at the center of this rectangle. Then you can take this much as the arc, and take this as the center, cut an arc, you are going to get point D. In the same fashion, get point B. Similarly, you can get this point with this much. Okay, once you have reached here, then you can take another radius, take this much. You are going to get the location for point E. Same fashion, get point A, get point O. So once you have done this, project lines upwards, to the right and then upwards. The intersection is going to give you the final as to how the finally the solid looks, right? Okay, so just think about this. There is a solid which has been kept in front of you. Okay, I think let me show you. Take a look. Step number one. Step number one. Step number one. Very well. Step number two. Okay. Axis inclined to HP. Step number two, top view. Step number two, front view. And now we have rotated it like this. The pentagon is clearly visible to us. Oh, no. 1 sec. गिर ही गया था मेरा cell phone. So two triangular faces in step two. Once again, let me go back to step two. Now we are rotating it in this fashion. Okay, this is how it would look finally, right? Take a look now at the main diagram. Take a look. This is how. So a little bit of imagination is very essential on your part to make sure that you are drawing it correctly, right? These two triangular faces are clearly visible, and behind these two triangular faces are these edges, OD and OE. So since they will not be visible directly as they fall behind a face, hence they have to be represented with the help of dashed lines, being a hidden feature, right? So, and this, by the way, what is this? That's the angle made by the top view of the axis. By the way, this angle over here is beta axis. Okay, this angle over here, theta axis, and we are done. In 13 minutes, we have solved this. Wonderful. Now let's talk about this beast of a problem from sectional orthographic, and this should only be attempted by those who have practiced at least 5 to 10 problems on this very topic. Okay, where you cut this entire object and you make the sectional front view. In this case, you have to create the SFV, viewing it from the direction X along this section A. Let me show this to you. This is section AA. Please watch the cursor. This way, then this way, and we are done. Okay, so that's section A. You have to view it from X, and on this viewing, you have to create the sectional front view. That's the first thing. Secondly, you've been asked to make the top view. Top view is easy. Yes. Right hand side view also has to be made. Again, right hand side view is to the left of front view. Mark my words. right hand side view is to the left of front view. So far so good. So I'm not going to be giving you a very step by step detailed animation video on this. Instead, what I have, I will just show you the solution. And because I am running very less, I have very less time. The examination is on 22nd of May, I suppose, for Mumbai University, and today is 19th. If I start making the animation, it will take me one entire day. Okay, that is a big task. Anyway, by just watching the solution, here's a step by step solution, not the animated one, but I'm sure you can understand it very well, especially for students who are interested in this very topic. And for others, you should skip this. Here we go. Let me show this to you. That's it. STV, top view, right hand side view, insert at least 10 dimensions. So I'm not really worried about inserting the dimensions. What I'm worried about is how do you approach this very problem. The first thing that you can do is to create three boxes inside which you are going to have your front view, your top view, and your right hand side view. Okay, if you watch carefully, this what is the length? This is the length. Length is equal to this over here in the top view, by the way, is the width, is equal to that is also the width. Think about it. And that's the height. I'm going to write down their values, exact values. Length, when you are viewing it from this direction X, you have access to the front view. 25 plus 55 will give you 80. 80 plus 20 will give you 100. 100 plus this radius, that is 120. So the length is 120. Agreed? Okay. Secondly, as far as the width is concerned, it is visible. The maximum width is 60. So 60. Done. What about the height, sir? Well, it can be worked out easily. This height over here, this is 20. Agreed? Yes. 20 plus 30 is 50. 50 plus this 20 radius is 70. So the height happens to be 70. Height here as well in the front view, right? So you can draw these three boxes. And by the way, this distance, you can take this as 10 millimeters, 10 millimeters, 10 millimeters, 10 millimeters, equal distances. That is the idea or our objective of orthographic projection. Anyway, let me move forward. Have a look how the drawing looks when we are just interested in making the front view. Although we have been asked to make the sectional front view, let me first show you how the object would look from the front, top, and the right hand side. This is how it looks. Let me get out of the way. This is exactly how the object looks. And make sure when you have a point over here, draw it in a tangential fashion. Here, the joining with the circle should be such that you follow the property of a tangent. Should be touch and go. Okay, that's one very important thing. And all of these transparent lines that you see, okay, the transparency has been reduced to 80%. These are what you call the projector lines. We take their help to make these sort of solid lines. Have a look. Right? Take pictures. Take screenshots. I don't worry. Even I will provide you an AutoCAD file, a Google Drive link, which you can download. And if you have access to the software, you can open it. You can zoom on it. You can see the different layers. I'll show you how you can select layer by layer. You can see the solid lines, you can see the center lines and stuff like that. Right? Okay. So you can see that this is where the section is happening. This way, then this way, then it will go down this way, then this way, this way, this way. When you do the section, your final sectional front view looks something like this. Right hand side view, and that's your top view. This is what has been asked in the problem. If you're confident creating the front view, you can easily make the sectional front view just a level up. Okay, with some common sense, you can achieve this diagram. And by the way, I drew this very quickly So if there are any issues, if there is any hidden feature that I missed, please let me know in the comments. Okay, I'll make changes to the original CAD file and re-upload it, right? And if you want to access all of these notes, the PDF notes, well, you're most welcome to my application, the link for which can be found in the description down below. And go to the Mumbai University folder inside the engineering drawing course. You will have access to this entire solution of uh, December 2024 paper. Okay. And by the way, all the best to all of you for the 22nd May paper. I guess this is going to be your second semester for the 24-25 batch, isn't it? Anyway, so this is the entire solution, and let me now take you to the AutoCAD file. Um, Here it is. By the way, just click on this. You can actually projectors, all the projectors can be switched off this way. Okay, just switch off the bulb. This is how it looks. You can switch off all the center lines. This, you can switch it on back. You can switch back on the projectors lines as well. So you can play with it. Basically, these are all the hidden features, right? So play with it. This front, right hand side view, top view. Okay, now after it is cut, this is full section, by the way, which divides the entire solid into two equal halves. You will see this from the front, and I've done the hatching here. Think about it. A lot of observation. If you want to really make this problem, if you don't want to create this drawing, it requires a lot of observation. You have to be very careful, and your skills are definitely going to improve if you invest time in this very question, but not in the examination. Okay, select the easy problems, score maximum marks. Thank you very much. Okay, so the next question is for 15 marks, and it is from the topic section of solids. The question is a bit interesting. Here you need to reverse engineer. You will understand what I exactly mean to say. Okay, let's go through the question once. I read it very carefully, and let's find out the details. So we've got a cone. Diameter is 60, axis 75. I'll be writing down all the data, don't worry, and this will be finished in the next 10 minutes. Okay, I'll be having a very quick approach to this. It is cut by a section plane. All right, inclined to HP. The section plane is inclined to HP. Take this as a section plane. It is inclined to HP this way, this angle, which you can see from the front, right? Such that the true shape of the section is a parabola with axis equal to 50 mm. Wonderful. Till now, the questions that we've attempted from this topic of section of solids have been framed in such a way that a cutting plane's location was given to you, or a section plane's location was given to you, and you were asked to make the corresponding true shape. Here, it is slightly different. As you can see, nowhere the inclination of section plane has been given. Rather, we have been said, or we've been informed that whatever the inclination is, it is with the HP, but we've been informed that the true shape corresponding to that section happens to be a parabola having a length of axis as 50. This is a wonderful information, and we can reverse engineer and get to the actual location of the cutting or section plane. Okay, what you need to draw is the sectional top view. You can see the section from the top. That's why we call it sectional top view, front view, and true shape of the section, which obviously is going to be a parabola. Now, back when I taught all of you guys the topic of conic sections, which where we learned the different methods of tracing a parabola, hyperbola, and even ellipse. This is somehow associated with that very topic. Try to remember, when do you get, or what are the conditions to obtain a parabola when you have been given a cone and a cutting plane? If you cut the cone in such a way that it is parallel to any one generator, then the conic section obtained is a parabola. You'll see that it is a live example. This entire problem will teach you that when you cut the cone in such a way that it is parallel to any one generator, the conic section that you obtain, the true shape that you obtain, is a parabola. You'll see this. I think we can start by solving this problem. What we've been given is a cone. Okay, the base diameter d, let me write it like this, is 60. Axis length is 75. Wonderful. Cutting plane or section plane, it is inclined to HP. You can find the inclination also once the drawing is done. You can see that. The true shape which we have is in fact a parabola. Let me just write para with axis of 50 mm. Okay, this is the information that we have. Now you need to reverse engineer and get to the cutting plane's location. How do you do that? Watch this video right till the end. Okay, so but please remember, whenever if you cut the cone parallel to any one generator, let me write it like this, generator, the conic section that you get is a parabola. Please note this. This is something that I taught long time back. Okay, now let's start. The cone, as we all know, it is resting on the HP. So here it is. Think about this. Think about this. Cone. Where is it resting? Resting with its base on the horizontal plane. Okay. From where can you see the true shape of the base? Sir, the true shape of the base can be seen from the top. What will you see? Sir, it will look like a circle, something of this sort. Divide the circle into, let's say, 12 equal parts. We want more points on the curve, so make more divisions of the circle. Simple logic. Now, let's watch this from the front. If you watch this cone from over here, from the front, what you see is basically a triangle. Okay, but do you know what this height is? Yes, sir, we know. Given in the question, 75. How much is this diameter? Sir, this happens to be 60. Wonderful. Here we go. Cone done. As far as cutting plane is concerned or section plane is concerned, we know very well that it is inclined to HP. What is the inclination? What is the magnitude of inclination? We don't know yet. How can we work this out? Okay, so far so good. We also know, corresponding to the cutting plane, the true shape that we obtain is that of a parabola. In fact, we also know that the parabola's axis happens to be 50 millimeters. That's the data which we already have. Okay, so this is a very important data, let me tell you, and this will help you get to the precise location of the section or cutting plane. Here we go. So the best way is, and I've already told you, cut the cone parallel to any one generator. Okay, but that generator should be the true length. Let me remind this. So there are only two such generators which I can see. O-1-, that is the true length of the generator. O-7-, that is also the true length of the generator. O-1-, O-7-. Why? The reason being very simple, because in the top view you can see it is parallel to the XY line. Therefore, its front view is going to represent the true length. Here also, O7, it is parallel to the XY line, and hence its corresponding front view, that is O-7-, will show its true length. So far so good. Okay, how do we approach now? What is the length of the axis? 50. So from here, keep your scale, keep the 0 of your scale over here and mark 50, length of 50. From here, go horizontal. Done. Let's say this is point Q. Now keep your roller scale over here at O-1-. Done. And then roll your scale backwards until you reach Q, and then make a line. This line should be absolutely parallel to this line over here, and if it is so, then this over here will qualify as the cutting plane. I know some of you still have some unanswered questions, which I'm sure will be addressed at the end of the video. Okay, even if I don't directly verbally say those answers to you, you'll still be able to work it out. Why I am doing this, attempting this, approaching this, in such a fashion. Okay, so far so good. So this is one way. Okay, from here at a distance of 50, mark a point, go straight, mark a point again, and then from here you need to produce a line which will be absolutely parallel to this generator O dash 1 dash. This is one way of approaching the problem. The other way is, where is the eraser? Simply use a mini drafter. What will I do? Here it is. Keep your mini drafter here, and then along the generator O dash 1 dash, tighten the screw. Okay, and then please note the zero of the drafter is right here. The zero of the drafter should slide along this horizontal line where my cursor is. Mark my words, the zero of the mini drafter should slide along this horizontal line where my cursor is now. Okay, and the moment you reach 5 on this generator, draw the line. Here it is. Okay, now you can clearly see we are at 5 and we are still at the zero of the horizontal line. This is going to be the precise location of your cutting plane. Now simply draw a line. Can you see this? Okay, that's your cutting plane. Now the idea is very simple. This is the base, so there are going to be 2 points, one at the front, one at the back. If we say this as B, A, this is going to be B, and here the corresponding front views are A dash, B dash. But first of all, I'm going to draw lines through all of these points. I still have a problem drawing a line from over here because it is going to overlap with these two generators. Makes no sense. So you won't be able to find all of these points are going to have their corresponding top views. How do you fit that? That's a challenge. Take a look now. A, B, A dash, B dash. Understood? This, by the way, is C dash, D dash, which I'll be addressing in a short while. Don't worry. This is going to be E dash, F dash. So if you watch E dash and F dash, 1, 4, 7, behind 4 there is 0.10. Here this is 5, 9. This should be 5, 9 with a dash. This should be 6 dash, 8 dash. Okay, so take a look from here. This is going to intersect at 2 locations, right? E and F, E dash, F dash. This over here, again, this is the 2 lines are extremely close. E, F, G, H, G, H. These 2 locations. Okay, and finally you've got this point as I dash. Here it is. Right? There is only one generator, therefore only 1 point. Here, actually there are 2 generators. This is O dash 8 dash generator at the back, and then O dash 6 dash generator at the front. Right? Okay, so as I said, there are 2 points remaining. Let me call these 2 points as C dash and D dash. Draw a horizontal line from over here, bring it downwards. Now with this much as the radius and with this as the center, rotate in both the clock and anti-clockwise sense. So these are the 2 points, C and D. And this is their corresponding front view. Okay, I want to finish this as soon as possible. Now join all of these points with the help of a smooth curve. This is what you're going to have. B, D, F, H, I, G, something of this sort. I missed something. G, E, I missed something. Anyways, it is going to look something of this sort. And yeah, this is the hatching. Okay, if you want, I can zoom into this. This is how it should look. As far as the true shape is concerned, I have not done any dimensions. By the way, you should write the dimensions. You should write the radius over here. How much is it? It is 30 if I'm not wrong. This over here, please do the dimensions. I'm leaving that for you. Otherwise marks will be deducted, might be deducted in the examination. Okay. Parallel to this section plane, draw an auxiliary plane. And now we wish to see from over here. So you need to, in this fashion, absolutely perpendicular. That means orthogonally. Draw lines through all of these points this way. You can do this. Okay, that's 90 degrees. Please note that. Now let's say you wish to have all of these points A, B, C, D, E, F, and this is for G, H, and this final line is for I, one single point. Let's say you wish to find point B. This is the radius Okay, keep one leg of your compass over here, other leg over here, and then this is the line for AB. Take this as the center. This is going to be point B. Okay. Uh, 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 Discard. Let me run the animation again. Okay, now how do you find point A? Again, one leg at XY, while the other leg of compass at A with this much as the radius, and then again, this is the line for A, this is the center, cut an arc. Say, in the same fashion, if you wish to find point D, this much will be the arc, and this is the line where we'll get point D. Take this as center, cut an arc, that's point D. So in the same fashion, you can obtain the remaining points. And when you join all of these points in a proper sequence, what you have is a parabola. And how? And by the way, this length that you see is known as the axis. And if you try to measure it, it will be equal to 50 millimeters. Please note that to the measurement. Okay. Anyway, so finally, if you wish to see, which portion has to be darkened, or which portion shall be kept light, it should look something of this sort. Okay, so you should be able to achieve this level of accuracy and precision in your drawing. I hope this has helped you immensely. Okay. Now let's talk about question number 5 and part A. This is for 9 marks. So in this problem, we've been given the front and top view of an object, and you need to create its isometric view. Very interesting question for 9 marks. And how can we solve this? Watch this. Here we go. First of all, you need to work out maximum length, maximum width, and the max height of the object. Well, this can be worked out very easily if you watch. Just a sec. How much is this distance? Sir, this is equal to the radius. This is the radius. That happens to be 30. This is 30. This is 90. So the length has got to be 30 plus 90, 120. Okay. How about the width? This over here represents the width. Width, if you watch, this radius between these 2 points, and then this radius, this part of the radius. So 30 plus 30 will give you the value as 60. The width 60. In the same fashion, you can work out the height, which happens to be 50. I know the dimensions are not that clear. You should make a complaint to the university to print good question papers. Okay, that's 50. So these are the dimensions with the help of which we are going to first of all create a box, and inside the box we are going to fit the isometric view. Very simple case. Watch. Here it is. How much is this length? Sir, this is 120. How much is this? This is the width. This is, by the way, the length. This over here will represent the width, which is given by 60. How about the height? That is 50. All the points. Okay. Join all the points. Done. I'm rubbing all of these things. If you want to note it down, you can by pausing the video. Done. Okay, sir. What's next? One more suggestion. Please remove these 3 lines. This one, this one, this one. This may create an iota of confusion inside your head. So get rid of it. Have a look. I wish to reach this location in the topmost plane. In the topmost plane. Okay. How do I get to this very point? If you watch, this over here is the radius. How much or how far is this center from the leftmost point? You can say this is at a distance of 30. Okay. Can you say, if I can just produce this line in the downward direction, how far are these 2 lines? Sir, these are separated by a distance of 30. So from here, here, we are going to reach here. The distance between the 2 is 30. So keep the 0 of your scale over here at a distance of 30. Mark a point and then make a parallel line. Okay. You have to either move in this fashion or in this fashion or in this fashion. Okay. That is why I have made this 30. here as well, right? This obviously will be 60, 60, you know this. Okay, so far so good. So this is the point, this is the point. Can you reach the center? Yes sir, we can reach the center somewhere here. Easy. Okay, now how much is this distance? Let me zoom in. Sir, the diameter of this small circle has been given as 30, hence the radius is 15. So that's 15, 15, 15, 15. Okay, 15, 15, 15, 15, and then can you draw this in this fashion? You always have to move parallel with respect to these isometric axis, right? Let me do this now. Smaller diagonal, larger diagonals. If you have seen my previous videos on isometric drawings, you know what I'm talking about, right? This is a little bit of construction that's needed to create an isometric circle. That's it. Now what we'll do is, from these two ends of these smaller diagonals, we are going to produce two lines, right? This will intersect the midpoint of the opposite two sides, okay, in this fashion, and from here also in this fashion. Once you're done with this, you can take this as the center and this much as the radius, rotate your compass. You can take this as the center, this much as the radius, then rotate your compass. This is the center, this much as the radius, rotate your compass. This entire isometric circle can be made with the help of a compass. Okay, and this is the radius. This is how you need to make it. Done. Okay, no problem. We are here. 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 Can we reach to this very point? Yes, sir, we can. How far are these 2 points? Sir, these are separated by a distance of 30. So from this very point, at a distance of 30, we are going to make a point, and then through this, we are going to make another isometric line. Done. Now, in the front view, you can see this distance is 10. Okay, so from here, at a distance of 10, you need to mark a point and then draw this line. Connect these two. Why? You can see the slope. So far, so good. Done. Okay. Now what? How do we reach here? And you can also see, this is deep. How much deep? This is 50 millimeters deep, right? The bottom edges won't be seen. It is too deep. That's why. Here also some part of the edge will be seen. I'll show this to you. But how do you make this? The top view of this very line looks like a rectangle. Okay, so there is going to be a rectangle which is going to be part of this incline. A very fascinating question. Just take a look. The first thing that we'll do is, let me make these 2 points first of all, and let me just demonstrate what these 2 points reflect. From here, here. These are the 2 points that I have just made. If I zoom in, you'll realize this entire width is 60. So from here, if it is 20, from here also it is going to be 20. Okay. So from these two extreme ends at a distances of 20 millimeters inwards, we are going to make these points. And we've made these 2 points. And then parallel to these 2 lines, we are going to make to another isometric line. Done. Okay. Now what? Now we wish to reach here. What is this distance? By the way, this distance is known to us, which is 15 millimeters. One more thing, if you watch carefully, do we know this distance? This, by the way, is 15. So from over here, okay, here, this is 1.5. From here also, between these 2 points, the distance again is 1.5. Done. So once you're done with this, just make these 2 lines. Okay, the problem is almost done. Want to see the solution? Here it is. Not so early. This is what was expected from you. As I said, there is a rectangular profile which is deep, and only this much edge will be visible. These edges won't be visible, won't be visible, won't be visible, as they fall directly below this plane. However, in the isometric view, this portion of the edge will be visible to you, which you can clearly see over here. Right? That's the final isometric view. Okay, so if you've got any doubt or query, write it down in the comment section down below. That was isometric view for you, question 5A. So this is question number 5, and that's part B, right? It is based on projection of solids. A very simple question, and you can obtain 6 marks easily. So we've got a square prism, side of base 40 mm, axis length is 60, has its corner of base on VP, interesting. And the base is inclined at 45 degrees to the VP. So far, in majority of the problems, we've seen that axis inclination is initially given to us. So if let's say axis inclination is theta, the basis inclination would be 90 minus theta. Or you can also say if the axis inclination is phi, with respect to the VP I'm talking about, the basis inclination is going to be 90 minus phi. Here, 90 minus phi is given to you. Right? Basis inclination has been given to you. So this is going to be slightly weird, but problem can be easily worked out in the next 3 to 4 minutes. Watch this. We need to draw the projections of the prism, and here we go with the solution. So the first thing we've been given is base. Base is that of a square, that is 40. Secondly, the length of the axis, or let me simply write the height of the prism is equal to 60. We have also been given that phi, base, the angle made by the base with respect to the VP is 45 degrees. So far, so good. Okay. The best way to understand this question is to draw a square prism. Here is a square prism. Let me draw this. This over here is 40. This is also 40. Let me write this 40, 40. Whereas the distance from the top to the base is 50. I hope you've understood the geometry of the object as well as the dimensions. Secondly, how should we go about step number 1? What shall be our assumption? For that too, I have got one sec. Take a look. This is your vertical plane. Okay. This is your horizontal plane. My drawing skills are not at its best today. V, P, H, P. Right? How do we keep the object? Let me give you 2 options. Base is inclined to VP. You can also say axis is inclined to VP. Inclined to VP. In case of projection of solids, if you have seen the first video in the playlist, when I explained you or demonstrated rather the standard procedure, what did I say? If the solid, let's say this solid, if the solid is inclined to, if the axis of the solid from this very point to the apex, if the axis is inclined to HP, assume that the solid is resting with its base on HP. Here you can clearly see the base is inclined to VP. That means the axis also, or axis indirectly is inclined to VP in this fashion. Axis inclined to VP. This way or this way, this way or this way. So you have to assume that the solid is resting with its base on VP. Okay, so from where can you see the true shape? Sir, the true shape of this base can be seen from the front, right? So you have to begin by making the front. What sort of a front view are you going to make? Let me give you 2 options. Okay, I'm going to keep the solid in 2 different fashions. Take a look. It is Please let me know which amongst the two is the correct way of keeping a solid. Is it option number 1, or is it option, I know this is looking very bad, option 1, option 2? If you watch, there is a very important information which has been given. Whenever you do this inclination, make sure that one of the corner of the base is or stays in contact with the VP. Okay, so this is the base. Just think about this. If you incline the solid in such a way that the base makes an angle of 45 degrees, what will happen? This edge will still remain in contact with the VP. However, here, if the solid has been kept in this fashion, and if you now incline the solid with its base making some angle, let's say 45-degree angle, the corner will stay in contact with the VP. So in the question, it has been clearly mentioned that you make sure that the corner of the base stays in contact with the VP. Therefore, option 2 is correct. We are going to go with option 2. And from where can you see this true shape of base? Sir, we can see this from the front, and thus we are going to start by creating this as our front view. If you're still wondering what about, how these corners have been marked, let me tell you. That's A, B, C, D, behind E, F, G, H. So when you're viewing it from front, A is at the front, E is at the back. A, E. Similarly, C is at the front, G is behind it, C, G. And then you can understand the remaining stuff. Okay. Now, let's take a look at it from the top. How many edges are you going to see? There are 3 edges. AE, DH and CG. HD and GC, this fashion. GC, DH, EA. This H, BF over here. Well, it can't be seen, but it can't be represented by a hidden line or a dashed line either. The reason being very simple, because it is being overlapped by a solid line above it. Okay, don't think about it. Don't worry. Now it's the time to make sure that this base makes an angle of 45 degrees. How much is this angle? Sir, that's 45 degrees. Okay. I think you know how to recreate the top view from step number 1 into step number 2. This is the basic. I won't get into the basics. My task, my prime objective in this for making this video is just to get you through all the solutions, right? You can do this on your own. Now project line upwards and then to the right. This is line for A. This is line for A. That's point A. Similarly, this is line for B. This is line for B. That's point B. In the same fashion, you can get all the points, right? Join them. This is how it is. Now try to think about this. We are kind of rotating the solid in this fashion, right? This edge would be visible to us. DH would be visible to us. CG would be visible to us from C to G. BF would be visible to us. This entire, when you are viewing it from over here, this entire face is visible to us. D, A, B, C is visible to us. Then these 2 edges are also visible to us. What is not visible is this HE. What's not visible is this EF. What's not visible is this A dash, E dash. Done. Finally, your object looks like this. Okay. Now do the dimensioning. That's 40. You can do it on your own, I guess. That's 60. And how about this angle? This is angle made by the base with the vertical plane given as 45 degrees, and that's it. We're done. All right, let's go. Final question, question 6, part A. So this is based on projection of line. Very simple problem, in fact, for 9 marks. Here we go. Let me just take you to the slide. Here it is. Let's read. One end A of a line AB is 15 mm above HP. So first information, distance from HP of point A is 15 and 25 mm in front of VP. So DA or distance of point A from VP is 25. Front view of the line measures 60 mm. Please remember, recall, front view is represented by A dash B dash, whose length according to the problem has been given as 60 millimeters. The length is 60 and it makes an angle of 50 degrees with the XY line. By the way, this is alpha, okay, 50 degrees. Very important information. Makes the problem really easy for us. Draw projections of the line and find its inclinations with HP. That means theta and phi has to be calculated. If the true length of the line is 75, so true length also has been given to us. Very well. So the first thing is to take into account these two datas, HA above, DA below. This way. Locus of A in front view, locus of A in top view. Easy? Let's implement this. Front view has been given as 60 millimeters, A dash B dash. And what is the angle that it makes? 50 degrees. So at an angle of 50 degrees, draw a line of 60 millimeters this way. Obviously, this is your front view. If this is locus of A in front view, that's locus of B in top view. Easy? Now, how do you proceed from here? We also have been given the true length, 75. So with the help of a compass, take a radius of 75 millimeter with A dash as the center, cut an arc. This is going to give you B1 dash, connect it with A dash. That's your true length. Easy. If you know the process, you'll be able to solve this problem without my help, without my assistance. Now we know we have to drop this. If this is B1 dash, this has got to be B1. Now with A as center and with AB1 as the radius, you can rotate this clockwise. Okay. You can rotate it further. If this is A dash, this is A, then this is B dash, and you need to project a line from B dash vertically downwards until it intersects this arc somewhere. This is going to give rise to point B. Easy. Connect B with A. Okay. Easy. That's the front view, A dash B dash. Corresponding top view, AB. Easy. So from here, a horizontal line can be drawn and which represents the locus of B in top view. So far, so good. Now you can also locate the true length. True length happens to be 75. So with the help of a compass, take a radius of 75 millimeters and with A as center, cut an arc. And by the way, connect B2 with A. This will be your true length. If you're still wondering, let me just reiterate. That's angle phi for you. That's angle theta for you. This, by the way, alpha, which was given to you. And this is beta, right? I have done all the calculations, the measurements, which you can check back the next slide. Okay, check your answers, right? Easy. Finally, on to the final problem. Question number 6 and part B. This is based on an isometric drawing. You have been given two views, front and top view. Based on this, you need to create the isometric view. Very simple, and this is for 6 marks. Can be done very easily. In fact, there is a prism hidden in these two views. Okay, a triangular prism, in fact. Let me take you to this slide. And here we go. So if you watch carefully, whenever you are drawing, whenever you are making any question on isometric view, try to work out the length and width. The length in this case is 80 and the width is, what is this? 58 or 56. Whatever it is. Take it 56, take it 58. I don't give a damn. And the height happens to be 70. Okay. Let me take a step-by-step approach. Let me make the base first. 80 by 56. Here it is. Done. Okay. Now what? Now what we can do is, if you watch carefully, this is a triangular profile from the front to the back. Sort of a triangular profile. That's why I was saying it would look like a triangular prism. So locate the center, and then from the center, you need to make this line. This is 70 millimeters. So locate the center and go 70 upwards this way. And then you can join this to make it a triangle, both in the front and at the back. Connect. Done. Now we wish to locate this center. If you watch carefully, this center of the circle is at a height of 20 millimeters. One more thing, this circle is having a diameter of 25, therefore the radius is going to be 12.5. Agreed? Okay, so the center's height, or center is at a height of 20. Let me fix it first. This over here, this is 20. Okay, so as I've said, this circle is having a radius equivalent to 12.5, 12.5 above, 12.5 to the right, to the left, and 12.5 to the bottom. Enclose it through this smaller diagonal. Produce lines, okay, to the midpoint of the opposite two sides, this way, from here also. And now you know the process, right? How to make an isometric circle. These are going to be your centers, and you need to make arcs. Those arcs, 4 arcs in totality, would look like, or would give birth to an isometric circle. This is how it's done. Now, if you take a look, this height is 40. Okay, and how far is this profile? Only for 40 millimeters. So first of all, let me make this right at the back, 40 up, and then go this way until it intersects this inclined line. 40 up from both the sides, and then to the right, to the left, until it intersects these two inclined lines. Done. Now you need to move forward by a distance of 40, 40, 40, 40 this way. Same stuff has to be repeated, and what you just need to do is make these two lines again, Done. Can you see the object? Can you visualize it now? Right. Let me just darken the portion which is going to be visible to us, and if you think carefully, you'll realize this much portion of the edge will be visible. However, this portion won't be visible. Take a look. Okay, this much portion of the edge is visible. However, this is not visible. Okay, so this is how you do the darkening, and that's your final isometric view for how many? 6 marks, I guess. Right? So if you have watched this video till here, a big thumbs up from my side, and all the very best to all of you, all the students from Mumbai University, for your engineering graphics paper. Okay, all the best from my side. Thank you very much for watching, and do share this video with your friends and classmates so that they can also benefit. Thank you. Have a nice day.